Okay, this is the video on fractions. It's Vedic math way. We will use sutras from Vedic math to simplify and manipulate the fractions. Okay, this is video number 7. Okay, let's continue. Outline. We will discuss this video in various sections, and first section is fractions. What are the fractions? There are two types of fractions. Let's see what they are. First is common fractions. Second is decimal fractions. Okay. Let's say in common fractions there are two numbers, a numerator and a denominator, and denominator divides the numerator. Let's see some examples of common fractions. Example 1 over 2. The two numbers 1 and a 2. 1 is a numerator and 2 is a denominator, and denominator in the bottom divides the numerator on the top. They're separated by a one horizontal line. Let's continue here. Another, so numerator is 1, denominator is 2, and the fraction is half, 1 over 2. Okay, let's continue here. Another example, 3 over 5. 3 is the numerator and 5 is denominator. Okay, let's continue. Another example, 7 divided by 8. 7 is the numerator and 8. About decimal fractions and see what those are. In decimal fraction, we have a decimal point that looks like this with digits to the right and sometimes to the left. If there are no non-zero digits to the right, we can remove the decimal point and the digits to the right. We have a whole number left. Okay, let's continue here. Example 0.1 is given by 1/10, represent 1 divided by 10. 0.593 is a fraction which represents 593 divided by 1000. Let's continue. 0.23 is a fraction which represents 23 divided by 100. Let's continue here. 0.37 represents 37. Decimal fraction types. There are exact fractions and there are recurring fractions. And 0.1 we saw in the last slide is exact fraction. Okay, and that's given by 1 over 10 is 0.1, which is exact. If you do 1 over 9, that's 0.1 recurring. That means 1 repeats forever. Continue. In 7 over 100, it's a 0.07, which is exact. If you do 7 divided by 99 with a sequence of 9s in denominator, we get 0.07 recurring. That means 0.7 repeats forever. Continue. In 27 by 1000, it's a 0.027 exact. If you do 27 divided by 999, 3 nines, it's a 0.027. 3 nines and 3 digits. And rest recurring. Let's continue here. Note that 27 over 999 is 137. That means 1 over 37 is 0.027. Common fraction types. Let's see what they are. We would just consider only the common fractions and what their types are. Let's continue here. There are 3 types of such fractions. Okay. First is proper fractions. Second is improper fractions. And third is mixed fraction. Let's continue. In a proper fraction, numerator is smaller than the denominator and the value is less than 1. Let's continue. Example is 13 over 17. 13 is numerator, 17 is denominator, 13 is smaller than 17, and the value of the fraction 13 divided by 17 is less than 1. This is a proper. Improper fraction. Numerator is larger than the denominator and its value is more than 1. Okay, let's continue here. Example is 21 divided by 19. 21 in numerator, 19 in the denominator. 21 is larger and its value is more than 1. Let's continue. In a mixed fraction, we split the improper fraction into whole and proper fractions. The above fraction is 21 divided by 19. 21 is 19 plus 2. And 19 divided by 19 is 1, and then plus 2 divided by 19 is 1 plus 2 divided by 19. We represent that as, this is what we represent like. So 21 by 19 is a improper fraction, and 1, 2 divided 19 is a mixed fraction. Okay? Where do we get fraction from? Source of fractions. Let's revisit division here. Okay? In division, there is dividend, which we divide by divisor to get a quotient and a remainder. Let's continue here. And this is a jingle from Glover's book. As divisor is what divides the dividend, and the answer is quotient with the remainder at the end. Let's continue here. These fractions come from this division here. Okay, let's see what I mean by that. Okay? There are basically two ways to represent a fraction. Okay, let's see what happens. Either you say dividend by divisor, that's we are trying to divide, say we are going to divide that dividend by divisor, we say dividend divided by divisor, okay, or we say like that, we divided already, we have quotient, we have divisor, we remainder, we have dividend, okay. If you say that quotient as a whole number, remainder as the numerator of the proper fraction part, and divisor as the denominator. So this is the two ways to represent. One is dividend divided by divisor, and before you divide, and this is after you divide. You get quotient as the whole number part, remainder divided by divisor as a proper fraction. Look at the sources of fractions and keep looking at it. Let's say what on previous slide we decided that there are two ways to represent a fraction. One is a dividend divided by divisor. Dividend and divisor are the terms for division, and in the fractions we usually say numerator divided by the denominator. So these are interchangeable to some extent. Okay, so which is dividend divided by divisor, and the other way is to represent a quotient as the whole number part, and remainder divided by divisor as the proper fraction part. Let's continue. We're going to look at example of this type on left. Okay, and example 1 is 5 divided by 9. It's of type dividend divided by divisor. Okay, that is before we attempt to divide, this is what it looks like. Okay, and it's a proper fraction which comes from 5 divided by 9. Okay, so 5 by 9 came from when we were trying to divide 5 by 9. Okay, let's continue here. Another example here. Now I will look at 23 divided by 17. Okay? And 23 is more than 17, and it is a improper fraction. It comes from trying to divide 23 by 17. Okay? And it's before we divide anything. It is improper fraction which comes from 23 divided by 17. That's before division. Okay, let's continue here. Now we want to do a fraction of this type quotient as a whole number, remainder divided by divisor as the proper fraction, and we want to represent this 23 by 17 as a quotient as a whole number, remainder divided by divisor as the proper fraction. That means I would have to divide and find quotient and the remainder. Divisor we already know. Okay, we would be doing this divisions using some subtractions, and I want to show you an example what I mean by that. Let's continue here. Another way to divide, we're going to do that. We'll take this example here. There are 13 pencils on a table in a store. The price is 3 cents for an individual pencil and 10 cents for 3 pencils, and you want to buy, somebody wants to buy all of them and pay the least amount of money, so they're trying to make groups of 3s so that they can save some money. Okay, let's continue here what this situation is here. On step 0, there are no groups here. All the pencils, 13 pencils are individual pencils, and if you buy 13 pencils, they would cost you 5 cents each, 65 cents in total. So what you do is you start making groups of 3. So on step 1, you subtract 3 pencils from the pencils and make a group. So you have one more group here. There are 0 before, now it's 1. And after subtracting 3 from 13, we have 10 pencils left over. Okay, let's continue. Now step 2, you take another 3 pencils away from these pencils. So 10 pencils over there. Now we get 7, and we got one more group. Okay, let's step 3, you may take another group of 3 pencils from the 7, a pile of 7, and we're leaving 4 here, and we got one more group. So we have now 3 groups. And step 4, okay, we take away 3 more pencils from 4 here to make a 4 groups, and only 1 pencil is left over. Okay, so let's look at what we just did. We just divided 13 by 3, where we pencil 3 pencils at a time. We get a quotient of 4, which was the whole number of groups here. Whole groups are 4, and quotient is a whole number, which is a 4, and remainder is 1 right here. In division, we generally pay attention to the last step here. Quotient as a 4, a remainder as a 1. If you look back here, when quotient was 0, remainder was 13. When quotient was 1, remainder was 10. When quotient was 2, remainder was 7. Quotient was 3, remainder is 4. These are all intermediate remainders. Okay, and quotient is 4, remainder is 1. This is the final answer. Final quotient is 4, and final remainder is 1. These intermediate remainders are called altered remainders, and we get to use these remainders in straight division method. When we overshoot in a division, we backtrack, and then we end up use a lower quotient and altered remainder. Let's continue. Now we want to represent the fraction in the type quotient as a whole number, remainder divided by divisor as a proper fraction. Okay, let's continue here. We'll consider the same example we did in previous slide, which is 23 by 17. That is the improper fraction. We would convert that into quotient as a whole number, a remainder divided by divisor. So we have to divide 23 by 17 to find quotient and the remainder. Divisor we already know. Okay, divisor is 17. Okay, let's continue here. How we do that? We'll make groups of 17 from 23 by subtracting multiples of 17 from 23. So we'll start subtracting 17s from here and make a group that will give me a quotient. Anything left over would be remainder. Let's see how that goes. So 23 is equal to, we just subtracted 17 from here, and here's my 17 I just subtracted. This is going to give me one group, and this is going to give me my first remainder and also the last remainder, because 23 minus 17 is a 6, and I cannot take any more 17 from here. Let's continue. From that means quotient, this is only one group here of 17, and 7, which comes from 17 divided by 17. Okay, we don't need 17, we need a group of 17. So it's one group. That's a quotient. A remainder. This part is remainder, which is 6 equal to 23 minus 17. What does that mean? That means that my fraction is quotient 1, remainder 6, and divisor 17. This is my mixed fraction, where quotient is 1. This is right here, and we had one group, we got one quotient. Remainder was 6. After we take out one group of 17 from 23, 6 were left over. Okay? And so 6 divided by divisor. Okay, 1 as a whole number. 6 divided by 17 is my proper fraction part. Okay, let's continue. And this is a mixed. Now let's get to next section here. Next section is reduced fractions and equivalent fractions. Okay, let's find equivalent fractions. Okay. By multiplication and by division, we can change a fraction to another fraction which is equivalent fraction. Let's see what we are talking about here. Multiplying both the numerator and the denominator. When we multiply the numerator, we are multiplying by, and when we multiply the denominator, that's like dividing by. But same number does not change its value. Okay? The two fractions with numerator and denominator are in this same ratio and are equivalent, and The sutra we are using is Proportionality Sutra. The two fractions with numerator and denominator in the same ratio are equivalent. Okay, and sutra we use is Proportionality Sutra. Let's continue here. Here is 3 over 5 is equivalent to 6 divided by 10. Why? 3 is to 5 in the same ratio as 6 to 10 is, we got 6 from 3 by multiplying by 2, we got 10 from 5 by multiplying by same 2. 3 to 5 is the same ratio as 6 to 10 is, these two are equal. Okay, let's do what's reducing fraction. What's that? Dividing both the numerator and the denominator by common factors to bring these two lowest terms is reducing fraction. Okay, reducing fraction is dividing both the numerator and the denominator by common factors to bring these two lowest terms is reducing fractions. Let's find out what I mean by it. Let's take an example here. We're going to reduce 6 divided by 10 to the lowest terms. Okay, first of all, note that 6 is even number, 10 is even number, both are divisible by 2. Okay, let's divide them both 2. Okay, so we divide 6 by 2, we get 3. Divide 10 by 2, we get a 5. Okay, now the numerator 3 and denominator 5 have no common factors. These two are divisible only by 1. And 3 and 5 are relatively prime. Okay, and so the answer reduced form is 3 divided by 5. Let's continue here. Let's do some examples of reducing fractions. Example 14 divided by 35. Let's see how do we reduce that. But both the numerator and denominator are divisible by 7. 14 is in the table of 7 and so is 35. Dividing both by 7, we have a 2 divided by 5. So if we divide 14 by 7, I have a 2. If I divide 35 by 7, I get 5. Let's continue here. So 14 divided by 35 is 2 divided by 5. So this is the reduced form. 2 and 5 have no common factor. They are relatively co-prime. Let's continue here. So another example here. We're going to do 27 divide 63. Let's see how do you do that. So look at digit sum of 27 is 2 plus 7 is 9, and digit sum of denominator is also 9. 6 plus 3 is 9. And you can refer about digit sum. You can check that out. Other video here. Okay, and that talks about digit sum and some more. Let's continue here. That means both are divisible by 9. So that means 27 is divisible by 9 and 63 is divisible by 9, and that's a common factor, and we would divide both by 9. That's what happens. Reduce that to equivalent form is, so if you divide 27 by 9, I get a 3, and 63 by 9, I get a 7. So it is 3 by 7. Let's do some more examples here. Example 315 divided by 735. Let's see how do we reduce that. Both the numerator and denominator are divisible by 5. See, 315 ends in 5 and 735 denominator ends in 5. So we reduce that to by divided by 5. So we get a 63 divided by 147. Okay. All right. Let's continue. Now let's see what happened here. Digit sum of 63 is 9. And digit sum of 147 is 3. Both are divisible by 3, and reduce that to, so we're going to divide that by 3, and then 147 by 3, we get a 21 over 49. Let's continue here. Okay, now let's see what's going on. Now both are, I can divide 21 by 7 and 49 by 7 because 21 and 49 are in the 7th table. So we get 3 by 7. Okay. And the now numerator and denominator are relatively prime. So 3 over 7 is the final reduced form. Let's continue. Let's do some more examples here. Let's continue. First example, 57 divided by 95. We have to reduce that. Let us see how we do it. Okay? Continue. Digits 57, numerator. Digit sum of 57 is 3, and that means 57 is divisible by 3 and is 3 times 19. After I know 3 is a factor, I can figure out the other factor 19. Okay, so 57. Okay, let's look at denominator. Denominator has 5 in the end, so it's divisible by 5. And after I know 5 is a factor, the other factor I can figure out is 5 times 19. 19 is the other factor. Okay, let's see what happens. So that means that I can represent 57 divided 95 by numerator of 3 times 19 and denominator of 5 times 19. 19 is a common factor which I can take out. Okay, so that means that my 3 by 5 is my reduced form. 3 and 5 are relatively co-prime, and that's my final reduced form. That means 57 divided 95 reduces to 3 divided by 5. Let's continue another example here. Okay, another next example is 51 divided by 119. Let's see how do we proceed. Okay, digit sum of 51 of the numerator is 6, and that means 51 is divisible by 3. And in fact, after I know 3 is a factor, I can figure out the other factor, and so 51 is 3 times 17. Okay, let's continue. So that means that to be able to cross out either one of the factors, the two factors in numerator are 3 and 17. I had to see if 3 is a factor of 119 or 17 is a factor of 119. And if neither is, then I can't cross out. That must be the reduced form. Let's continue though. Okay. So is 119 divisible by 3? No, because digit sum of 119 is 2, which is not in the same set as 3, 6, and 9 are. So 119 is not divisible by 3. Okay. Let's continue. Is it divisible by 17? We will use the method we discussed before in a pseudo division method, and it's in this video here, but we'll do the subtract groups of 17. In dividing, we subtract groups of 17 from 119 to see if remainder is 0. If remainder is 0, it's divisible. First, we subtract our 5 groups of 17, which is 85. If I subtract 85 from 119, we get 34. 34 has 2 more groups in here and no remainder. So that means here 5 groups were here, 2 groups were here, 7 groups. That means quotient is 7, remainder is 0. So that means 119 is divisible by 17, and in fact it is equal to 7 times 17. Let's use those factors now. Numerator is 3 times 17, denominator is 7 times 17. Okay, 17 is a common factor which we can cross out. Okay, that means that final reduced form is 3 by 7. 51 divided by 119 reduces to 3 divided by 7. Let's continue another example here. Okay, 65 by 91. 65 has a 5 as a factor, and it is 5 times 13. Okay, and 13 is a factor of 91 also, which is 7 times 13. Let's see what happens. The numerator is 5 times 13 and denominator is 7 times 13, and 13 is a common factor. We can cross that out and we get a 5 over 7 as a final reduced form. So 65 divided by 19 reduces to 5 by 7. 51 by 119 reduces to 3 by 7. 57 divided by 95 reduces to 3 by 5. Okay, let's do another example here. Example I'm going to do here is 429 divided by 715. Okay, let's continue here. This time I'm going to do a digit difference of 715. Okay, which is a dd of 5 plus 7 minus 1, 5, and a 7 is 12, minus 1, 11, and this is more than 10, so we do it again. 1 minus 1 is 0, so digit difference of 715 is 0. That means denominator is divisible by 11. Let's continue here. And 429 for numerator. Digit difference is 9 plus 4, 13, minus 2 is 11. Okay, and same digit difference of 11 is 0. So that is 429 is also divisible by 11. Let's continue. And so digit 429 is 11 times 39, and 715 is 11 times 65. Let's continue here. And if you want to know digit differences, you can refer to the section here, divisibility by remainders, and this is the video on YouTube. Okay, so let's continue. So we have 11 times 39 for the numerator and 11 times 65 for the denominator. 11 is a common factor. Okay, so we cross that out, and so next is we have a 11 is common factor, and the fraction so far is equivalent fraction is 39 divided by 65. Let's continue here. Okay, now 39 has 3 as a factor. Okay, so and 39 is 3 times 13, and 65 has 5 as a factor, and it is equal to 5 times 13. Okay, so let's see what happened now. So that's 3 times 13 as numerator, 5 times 13 in denominator, and 13 as a common factor we can cross out. Yeah. Dividing both the numerator and denominator by 13, the fraction becomes 3 by 5. And that's my final reduced form. 3 and 5 are relatively co-prime. Okay, and so that's my final reduced form, 3 by 5. Let's do some exercises now. Express the following in the lowest terms. Let's see what the examples are. First exercise, 10 divided by 15. Okay, let's continue. Next, 13 divided by 39. Next, 12 divided by 16. Next, 16 divided by 64. Next, 33 divided by 36. Next, 24 divided by 56, and so on. That's more. Okay. Continue with next section here. In next section, we'll talk about proportionality sutra and how does that apply to the fractions. Okay, let's find the missing number is the problem here, and problem is on left we have 7 divided by 13 equal to, on the right we have 35 divided by what, so that the two equality holds. Okay, let's continue here. What do we do? Numerator on the right is 35, and 35 is 5 times 7. So that means we have multiplied by the numerator on the left by 5 to get 35. 35 is 5 times 7. Okay, that means numerator on the right is 5 times that on left. Okay, that means we have multiplied the numerator by 5 to get 35 from 7. We have multiplied by 5. Let's continue here. We need to multiply denominator also by 5. Okay, this is equality sign. The two have to be equal, and this fraction has to be equivalent to this fraction. We already multiplied 7 by 5 to get a equivalent fraction. We need to multiply 13 also by 5. Okay, so let's see what happens. So missing denominator is 5 times 13. The what here is 65. So the question mark sign here is represents 65. Okay, let's see what's going on here. That means 7 over 13 is 35 over 65, and the missing number is 65. More examples here. So you have 37 by 89 equals, okay, to 356 in denominator and what in the numerator. Okay, let's see how do we proceed about that. Okay, proportionality is 356 denominator divided by 89, which is 4. Okay, that means we got 356 from 89 by multiplying by 4. We have to get this what from 37 by multiplying by 4. Okay, let's see what happened. So missing numerator is 4 times 37, which is 148. Okay, this what thing is 148. Okay, and equivalent fraction with 356 as denominator is 148 divided by 356. Equivalent fraction of 37 divided by 89 with the denominator of 356 is 148 divided by 356. Do some exercise here now. Okay, find the missing number. On left we have 2 divided by 9. On the right equals what divided by 36. Let's continue. Next exercise. On left we have 9 divided by 13 equals 45 divided by what? Okay. On left we have 11 by 23 equals what divided by 92. Okay. Let's continue here. Another example. On left we have 17 divided by 29 equals 64 divided by what? Okay. Next section. We will work on improper and mixed fractions now in the next section. Yes. Okay, let's convert to improper fractions. So we would take out a mixed fraction and we would convert that to improper fraction. Let's continue here. So we have a example is 2 as a whole number, 5 divided by 12 as a proper fraction. Let's continue here. So 2 is whole number, okay? That's a group of 12s here. So that's 2 plus 5 over 12. We just split that into two sections here. 2 plus 5 over 12. This is added up plus sign. Let's continue here. Now 2 is a 2 divided by 1. Okay? We multiply and divide by 12 here on the for 2. 2 times 12 in the numerator, 1 times 12 in the denominator, plus the proper fraction part 5 over 12. Okay, let's continue here. This is 24 twelfths and this is 5 twelfths. 24 plus 5 is 29 twelfths. So we say in numerator we get a same common denominator here. 24 plus 5 is the numerator and 12 is the denominator. Okay, so that is equal to 29 over 12. This is my final answer. That's my improper fraction which represents the mixed fraction. Given mixed fraction was 2 as a whole number, 5 divided by 12 as the proper fraction. After we took out 2 here and then we multiply and divide by 12 on and also added the fraction, the given proper fraction, we got a 29 over 12. Let's do another example here. Example 5 and 12 by 17. Okay, so we do same thing. We try to combine some steps now. So that is the 5 whole number. 5 times 17 divided by 17. We multiply 5 and multiply 5 by 17 and divided by 17. Then added the proper fraction part. Okay, so that means common denominator here. So the 17 is denominator and 5 times 17 plus 12. Okay, so that's 85 here and 12 here. That's 85 plus 12 is 97. 97 by 17. So this improper fraction, this mixed fraction we started with, and that we change that to improper fraction. 5 as a whole number, 12 over 17 as a proper fraction. After we multiplied and divided 5 by 17 and added to 12 over 17, I got 97 over 17. That is my improper fraction, which represents the mixed fraction of 5 as a whole number, 12 over 17 as a proper fraction. Now let's convert to a mixed fraction now. Okay. We start with the example of improper fraction of 73 divided by 23. You know that we need to divide here, find a quotient and the remainder, and we would do that by taking groups of 23 from 73. Okay, let's do that. So we take one group out, and that intermediate remainder is 73 minus 23. So one group means we've got 1 in a quotient and remainder is 50. At this stage is 50. So 50 by 23. That's my intermediate results. 1 as a whole number, 50 over 23 as my fractional part, which is still improper. Let's continue here. We take out another group of 23 here. That means remainder at this stage is 50 minus 23. So this is one group of 23 that add 1 to my quotient here, and that adds 1 to my whole number. Let's continue here. My whole number is 2 now. Remainder at this stage is 50 minus 23 is 27. So it's still improper. So we take out another group of 23 from here that would add to the whole number part, and would final remainder would be 4. Let's continue here. So we just change that to convert that further to 3 as a whole number and 4 divided by 23 as a proper fraction part. This is now proper. Okay, so this is the final mixed fraction representation of the number 73 by 23. We had to find a quotient. We had to find the remainder of this division here, and we did that by taking groups of 23 from the numerator. Okay, let's continue here. Another example. Example 2. We're going to now we're trying to divide 193 by 45 and get a quotient and a remainder. And how we do that? We take our groups of 45 from 193. Let's see what numerator looks like. Okay, numerator is 193. Okay, let's continue. We take out one group 45, and remainder at this stage is 193 minus 45, which is 45 as one group, and 148 is the intermediate remainder at this stage. Okay, let's continue here. Now I get a little bold here and took out two groups of 45. Okay. 90 is the two groups of 45, and that's mean 148 minus 90 is my intermediate remainder at this stage, and that's what that is. Let's find out. That's 58 here. Okay, and now 58 is still more than 45. I can take another group here. So let's take another group 45 from here. So then I get 45 plus 90 plus 45 plus 13 here. 58 minus 45 is 13. Yeah, I combine the steps here now, because instead of saying 58 minus 45, I just combine those steps and go to 13 here. Let's continue here. So, so fraction is, numerator is 193 is 45, one group of 45, two groups of 45, one group 45 plus 13, and that one is numerator plus denominator. So now we know that whole groups are 4, one here, two here, and one here, and remainder is 13. So give me 4 as quotient for the division here. That's my whole number, and 13 over 45 as my proper fraction. 13 is the remainder. Let's do some exercises here for conversions. Okay. Let's do two mixed or whole numbers. 8 over 7. Let's convert to mixed fractions. 23 by 9. It's improper fraction. Convert that to a mixed fraction. Do the same for 116 divided by 23. Next example, 225 divided by 75. Next example, 306 divided by 51, and so on. Okay, now we're going to convert that to improper fraction. 2 divided by 5, do 2 as a whole number, and 5 divided by 7 is a fraction part. 5 as a whole number, 13 over 15 as a fraction part. Let's continue here. 8 as a whole number, 23 by 93 is a fraction part, and some more. Next section here. Next section will do additions and subtractions using fractions. So we're still on fractions part. We're doing additions and subtractions using fractions. Let's do a first examples here. We're going to do special cases first of equal denominator. Okay, denominator matches here. Okay, let's continue. So example is 5 over 17 and 7 over 17. So this is a denominator match. This is 5/17 and this is 7/17. If you had 5 apples and 7 apples, add them together, you had 12 apples. You add 5 and 7. Here 5/17 and 7/17 will add them together. We can make a 5 plus 7, that's it, 12/17. Let's continue what we do here. So that is equal to 5 plus 7 and of 17th, 12/17. Okay, let's continue here, and that's equal to 12/17. Now sutra we need to apply here is vertical and crosswise. Let's see if we try to apply sutra, what happens. Okay? We do that again. 5 over 17 plus 7 over 17 is equal to, let's see how we apply sutra. In numerator, apply vertical and crosswise. In denominator, you apply horizontally. Actually, we're trying to do crosswise in of sutra, vertical and crosswise. We only use crosswise part. Okay? And in denominator, we apply horizontally. This is extension of vertical and crosswise, also includes horizontally. Okay, let's continue here. So in numerator, we have a 5 times 17 right here, and 7 times 17 right here. In the denominator, we have 17 times 17. Okay, let's see what happened now. And there's a common factor of 17, and cancel that out by multiplication and by division. Okay, let's continue, see what happens. So that means we get 17 is a common factor. We extract that out, and now we're going to cancel that out. 17 times by 17, cancel out common factor, and we'll have a left over 12 over 17. Okay, so cancel that out, and that get 12 over 17, the same answer. Even though for special cases it's easier to apply a special case to get answer, but sutra still applies. Sutra, vertical and crosswise, still applies. In the numerator, it's multiply crosswise and add, or subtract. It's multiply crosswise. In denominator, is multiply horizontally. Okay? Okay, let's continue here. We will revisit the same example again and see if there's another way to attack the problem. Let's continue. It's 5 divided by 17 plus 7 divided by 17. Let's continue here. First, we're going to extract out the common factor. say 17 is common factor here, we would extract that out. Let's see what do we do here. So first, I just read out the same equation here, okay? 5 over 17 plus 7 over 17, okay? Just move that thing little slightly higher. I need some room on the bottom. Okay, let's continue here. So I extract out 17 as common factor from this 17, and now this 17, I got 1 here and 1 here, okay? 17 is a common factor. We took it out from both the denominators. Okay, let's continue here. Now I'm going to apply in numerator, we're going to apply crosswise. In the denominator, we are going to apply horizontally. Okay? So let's see what do we do here. It's 5 times 1 plus 7 times 1. That's in the numerator. The denominator is 17 and 1 and 1. 17 times 1 times 1. Okay, let's simplify that. So that is 5 plus 7 on numerator and 17 in the denominator. Okay, let's see. So that is 12 by 17. Okay, so we can apply vertical and crosswise straight. Then we had to reduce that and extract our common factor. We can extract our common factor before, okay, right here, and then we ended up in 12 over 17, and which is same thing as 5 plus 7 divided by 17. Okay, so for common denominator, we can simply add the numerators, and we can apply vertical and crosswise too. So vertical and crosswise applies even though a simpler way to solve these additions is possible. Special cases, simple way is possible. By common denominator, we can add numerators, and but the sutra still applies. Okay, and we can also extract out the common factors here instead of extracting out common factors in the end in reducing the fractions. We can here we're going to have a proportional denominator. Let's see what we do here. Example is 4 over 9 minus 7 over 27. Okay, so this is 9 and 27. 27 is 3 times 9. 27 is proportional to 9, and 9 is sub-proportional to 27. So let's see what we do here. Find equivalent fraction for the first term such that denominator is 27. Okay, so we would convert that to equivalent fraction, so to get a 27 in the denominator. Okay, so what are we trying to do? We're trying to solve this equation here. What divided by 27 is minus 7 times 27. Okay, so and that is 12 over 27. 27 is 3 times 9, this 27, so we have to multiply 4 by 3 to get 12. Okay, so the what here is 12. Okay, so now we have 12 over 27 minus 7 over 27. There's a 12 27ths minus 7 27. This is like 12 apples, and you give away 7 apples, how much left? So from 12 27ths, we give away 7 27ths, how much are they left? Okay, and that is 12 minus 7 divided by 27. So it's a common denominator. We can subtract out or add out what's need to this sign is. We can apply this sign to the numerators. 12 minus 7, which is equal to 5 over 27. Okay, so in proportion time denominators, we need to convert the fractions to equivalent fractions such that the denominators match. Okay, and we try to match the denominator of the higher value. Okay, let's continue with the same example here. Now we would apply the sutra vertically and crosswise. Example is 4 divided by 9 minus 7 divided by 27. 27 is a multiple of 9, is proportional denominators. Okay, let's see what we do. We apply crosswise in the numerator. We could apply the sutra here and horizontally in the denominator. Let's see what we do here. That means 4 times 27 minus 7 times 9. Okay, 4 times 27 is this number here, minus 7 times 9 is this number here. In the denominator, we do horizontally 9 times 27. 9 times 27 in the denominator horizontally. Okay, so let's solve that out. So this is 7 times 9, and this is a 4 times 3 times 9. I extracted out the factor 9 here. So we in the numerator we have 9 times, in the parentheses 4 times 3 minus 7. In the denominator we had 9 times 27. 9 is a common factor. we can cross out. Okay, so now we have a 12 minus 7 divided by 27, which is 5 over 27. Okay, so same answer we got before. Let's continue here. So I'm going to take this example again, count factors in denominator. Okay, 3 over 10 plus 4 over 15. Common factor is 5 here. Okay, so let's see what we do. I think we're trying to make a change fractions to equivalent fractions with equal denominator. In the previous slide, we had there are multiples here, proportional. Okay, now it's a common factor, so we have to make it change these to equivalent fractions with a common denominator. Okay, let's see what I do. Larger denominator is 15. Its multiples are 15 times 2 is 30, and 30 is multiple of the smaller number denominator. The books use lowest common multiple, and I have not shown you LCM yet. Change both fractions to equivalent fractions with equal denominators. Okay, let's see what happens. So we are change that to 3 times 3 divided by 10 times 3 for left part of the plus, and 4 times 2 divided by 15 times 2 for the right part after the plus sign. So before the plus sign we multiply and divide by 3, and after the plus sign we multiply and divide by 2. We got 30 in the common denominator. Okay, now we can add the numerators here. Okay, so that gives me 9 over 30 and 8 over 30. So this 9/30th and 8/30th we are adding together, we got a 17/30th. Okay? Answer is 17 over 30 is the answer for when you add 3 divided by 10 plus 4 over 15. Let's continue. We do the same example we did before, but we'll apply the sutra vertically and crosswise. 3 divided by 10 plus 4 divided by 15. We did before. Okay, we did sutra now. Apply crosswise in the numerator and horizontally in the denominator. Let's see what happens. So with 3 times 15 plus 4 times 10. 3 times 15 is 45 plus 4 times 10 is 40. And the denominator is 10 times 15. 10 times 15 is 150. 10 times 15. Let's continue. So that is equal to 45 plus 40 is 85 divided by 150. Okay. Now we have 5 is a common factor here. We subtract, cancel that out. That gives me 17 divided by 30. That's my reduced form of 85 divided by 150. See, we divided by 5 here. We could have divided the 5 by extracting out a common factor in the beginning here. Okay. So let's revisit this example here. Common factor denominator. Okay. So with 3 by 10, let's say what do we do now? Okay. We now extract our common factor 5 we discussed before from the denominators. Okay. So take our 5 common factor from 10. 10 becomes 2. When we take 5 factor out from 15, 15 becomes 3. Okay. Continue here. When crosswise in the numerator and horizontally in the denominator again. Okay. Let's continue. That's 3 times 3 plus 4 times 2. 4 times 2, 3 times 3 is 9 plus 4 times 2 is 8. And in the denominator 5 times 2 times 3. 5 times 2 times 3, which is 30. Let's continue here. That is 17 divided by 30. 3 times 3 is 9 plus 4 times 2 is 8. And that's the same answer we got before. Now we will do a general case. Okay. Sutra applies vertical and crosswise applies always, even when there are special cases and a simpler way to attack the problem is possible. Okay, let's go to general case here. Example, we'll take 3 over 13 plus 5 over 11. No common factors, no multiples, no proportional denominators. Okay, so let's continue. So we apply crosswise in numerator and horizontally in denominator. So let's see what happens. 3 times 11. 3 times 11 plus this crosswise. 5 times 13 crosswise plus 5 times 13 plus come from here. Okay, in the denominator is 13 times 11. Okay, let's see what happened now. So we have a 3 times 11 is 33, 5 times 13 is 65. So 33 plus 65 in the numerator and 13 times 11, 143 in the denominator. Let's see what happened now. So that is equal to 98 divided by 143. When we add these two terms together, first fraction is 3 divided by 13, second fraction is 5 divided by 11, and answer is 98 in the numerator, 143 in the denominator. 98 divided by 143. Do another example here. We'll use the sutra vertical and crosswise. It's a general case. Example, I'm going to use half minus 1/3 plus 1/9. Okay, 1 over 2 minus 1 over 3 plus 1 over 9. There is no proportionality, okay, no common factor, okay, and no equal denominator. Okay, 1 over 3 and 1 over 9 do have a proportionality situation when 9 is a multiple of 3. If you wish to solve this section minus 1 over 3 plus 1 over 9 separately, that's up to you. But I'm going to solve them all three fractions together. Okay, 1 over 2 minus 1 over 3 plus 1 over 9. Okay, and we will use vertically and crosswise. Let's see what I'm trying to do here. We'll do crosswise in the numerator and horizontally in the denominator. Okay, let's continue. Here's a 1 here. Okay, I'm going 3 is a crosswise term for 1 and 9 is also crosswise term from 1. So I'm going to multiply 1 by 3 and also by 9. 1 times 3 times 9. So this is a crosswise for this one, and minus here, we get the minus here. This minus and this minus matches. Now we'll take over this 1 here. The middle one for 1 over 3 is a crosswise term is 2 here, and another crosswise term is 9 here. Crosswise is 2 and crosswise is 9. So I'm going to multiply 1 by 2 by 9. That is 1, 2, and 9. For the middle one, 1/3, which is 1 over 3, the numerator part is 1, 2, 9. Contribution of 1 over 3 to the numerator is 1 times 2 times 9, and this minus and minus matches. There we had a minus between half and 1/3. There's a minus here. Now we have plus here and a plus here. For this 1 over 9 term, for one crossing term is 3, another crosswise term is 2. Crosswise term 3, crosswise term 2. So I'm going to multiply 1 by 2 and also by 3. So 1 times 2 times 3 is the contribution of this 1 to the numerator. And denominator, we're going to multiply horizontally 2 times 3 times 9. 2 times 3 times 9. That's my denominator here. 2 times 3 times 9. Let's continue. 3 times 9 is 27. That's 27 here. The minus here and minus here. We get minus continues here. So 1 times 2 times 9 is 18. This is 18 here. This plus here and this plus here. This plus follows that plus here. Okay? And last term in numerator is 1 times 2 times 3, which is 6. And denominator, it's a 2 times 3 times 9. 2 times 3 is a 6. 6 times 9 is 54. Okay, so that's 54 right here. Let's continue. And that is equal to 15 divided by 54. 27 minus 18 is 9. 9 plus 6 is a 15. So 15 here and 54 in the denominator. 15 and 24 both have a common factor. Common factor is a 3. And let's go divide out by 3, and that's what comes up. Okay, so if you divide 15 by 3, I have 5. If I divide 54 by 3, I get 18. So final answer is 5 over 18. When I half minus 1/3 plus 1/9, it adds up to 5 over 18. Okay, let's continue exercises now. Okay, we do the needful add and subtract. Whatsoever sign says, we do that for the following fractions. So 1 over 3rd plus 2 over 3rd. Okay. Next exercise, 11 over 20th plus 3 over 4th. Next exercise, 7 over 12 minus 29 over 84. Next, 5 divided by 7 minus 19 divided by 35, and some more. Okay, let's continue. We'll now go into next section, and next section is about comparing fractions. We would compare some fractions here, see which one is larger and which one is smaller. Okay, let's compare some fractions now. Okay. Example, what we're trying to do is which fraction is bigger. First example, 2/3 or 5 over 7. Okay, let's continue. So what do we do? Apply crosswise. 2 times 7 is 14 and 5 times 3 is 15. I got 15 larger number from second fraction. So 5 over 7, which second fraction is bigger. Let's continue. If you were to do the same thing using a conventional math, you would do a 3 times 7 is 21. 21 is for denominators. We multiply 2/3 by 21. We multiply 5 over 7 by 21. I got a 2/3 by 20 times 21 is 14, and 5/7 times 21 is 15. We just did crosswise here. In Vedic math, we can compare the fraction using a crosswise. In conventional math, you have to multiply out by the product of the denominators. And in my opinion, this one is simpler and easier. Okay, let's continue. Okay, you can also use ratios here. So we say 2/3 to the ratio of 5 or 7, and we want to find out which one is bigger. Okay, let's see. It's the denominator part is that bothers us to comparing. Okay, so we just would remove those one at a time. Multiply by 3 to remove 3. So 2/3 to 5 or 7 are the same ratio as we multiply this by 3 and this by 3. Okay, when we multiply first number by 3, we get 2. When we multiply second number by 3, I got 15 by 7. Okay, let's compare. I continue here. So now 7 is a denominator here, and I want to remove that too. Okay, so multiply by 7. So 2/3 in the same ratio as 5 or 7, in same ratio as 2 times 7 is 14, and 7 times 15 by 7 is 15. So 15 is still bigger. Second, I got 15 second number from the second number here, and which is bigger, so that is second fraction is bigger. Okay, let's continue. That means 5 over 7 second fraction is bigger. Let's take another example now. Is the 3/4 or 5/6? Okay, let's continue. Okay, apply crosswise. 3 times 6 is 18. 5 times 4 is 20. 20 is larger than 18, so this is second fraction is bigger. Okay, let's continue. 5 over 6 second fraction is bigger. Let's continue another example here. 18 over 27 or 17 over 33. Do the crosswise again. Apply crosswise. 18 times 33 is 594. 17 times 27 is 459. Okay, and so this is larger. So first number is larger. First fraction is larger. Okay, that means 18 over 27. First fraction is bigger. Okay. Let's do some exercises here. Which is biggest? 2 over 5 or 15 over 7? Let's continue. Is 8 over 9 or 7 over 15? Let's continue. Is the 41 over 50 or 8 over 9? Or next, 3 over 7 or 12 over 21? Next, is 13 over 20 bigger or 17 over 39? Let's continue. Okay. Now we're going to write the smallest one. Okay. Is 5 over 40 smallest or 17 over 51 smaller? Continue. Is 19 over 101 or 79 divided by 101? Okay. Now arrange in the ascending order. Smallest fraction first and the largest fraction last. And we are trying to rearrange these numbers. 19 over 57, 28 divided by 35, and 36 divided by 72 in ascending order. Smallest number on the left and largest number on the right. Okay, let's continue. Next section we're trying to outline is a multiplication and division. Next section we will discuss how to multiply and divide fractions. We discuss multiplication first, and let's see how to multiply. Here are my steps I got from the Glover's book. 1. Convert all whole numbers and mixed fractions into improper fractions. Okay? Let's continue here. A whole number of 3 means 3 by 1. 3 divided by 1. Multiply numerators to get numerator of products. So we're going to first convert the numbers to a improper fractions. Then we're going to multiply numerators to get numerators and denominators and multiply denominators to get denominators of products. Okay, let's continue here. Then reduce to the lowest term if not already in that form. Convert improper fraction to whole numbers or to a mixed fraction. Okay? So these are the steps to multiply fraction. An example for multiplication. First example is 2 divided by 3 times 5 divided by 7. So numerator is 2 times 5, which is 10, and denominator is 3 times 7, which is 21. Okay? So numerator is 2 times 5 is 10, denominator is 3 times 7 equals 21. Okay? So that is 10 over 21. Let's continue. Another example. 9 over 17 times 7 divided by 13. Let's continue here. Numerator 9 times 7 is 63. Denominator 17 times 13 is 221. Let's continue here. So it's a 63 divided by 221. Okay, that's a proper fraction, and there are no common factors to divide out by. Okay, 3 is a factor here, another 3 is, 7 is, neither 3 is a factor here, and neither 7 is. Okay, let's continue here. So another example, 3 times 5 over 13. First we need to convert 3 to a improper fraction. Okay, so we change 3 to a 3 divided by 1. Okay? So the 3 divided by 1 times 5 divided by 13. In numerator 3 times 5 is 15. In denominator is 1 times 13 is 13. Okay, so that's 15 over 13, and that's improper fraction. Now you know how we need to divide that out and find a quotient. You know what we did? We take groups of 13 from 15. We take one group out, make one quotient of 1, and remainder is 2. So whole part of the mixed fraction is 1, and the proper fraction is 1, 2 over 13. So let's continue. So that's my mixed fraction part, which is equivalent to 15 by 13. I got 1 from here because I had one group of 13 in 15, and remainder was 2, and that's what we got in here. Okay? And 13 as a in denominator stays here. Okay? Another more examples of multiplication. Example is 3 times 5 divided by 6. So we change 3 to a improper fraction of 3 divided by 1 times 5 over 6. Okay, and that is 3 times 5 is 15, and 1 times 6 in denominator 6, 15 divided by 6, and they have one common factor of 3. Let's continue. So that's 3 times 5 in the numerator and 3 times 2 in the denominator. So we cross out these 3's here, common factor, and what we have is a 5 over 2. Okay, let's go do it again here. So which is 2, and now we got to make a mixed fraction out of improper fraction. This is improper fraction, so make 5 over 2 is same thing as 2 whole number and 1 over 2 as a proper fraction part. Okay, let's continue here. Let's do it again. 3 times 5 over 6. So we had to divide that out 3 in the end. See if we try to divide that out before. Okay, let's see what happens. So we got 3 divided by 1 times 5 over 6. Same step we had before. So let's see what we do now. I cross out the 3 common factor 3 here. 3 and 6 have a common factor 3. So we divide this 3 by 3 to get a 1. We divide this 3 by 6 by 3, get a 2. Okay. Let's see. Now we got a multiply out the numerator 1 times 5 and denominator 1 times 2. 5 times 2. It's improper fraction. We change that to a mixed fraction. Let's continue here, and which is 2 and 1. Okay, let's do some more examples here. Example: a mixed fraction with 1 as a whole number and 2 divided by 3 as a fraction part, which is a proper fraction, times 3 as a whole number and 5 over 7 as a proper fraction part. We're going to multiply these two numbers together. First thing is we convert them into improper fractions. So that's equal to 1 as a whole and 2 by 3 becoming 5 over 3, which is This is the quotient. This is a group of 3. So 3 plus 2 is 5. 5 times 3. Now this is a 3 groups of 7. 7 is a denominator. Is 3 groups of 7. 3 times 7, 21 plus 5. 26 divided by 7. So we have a 26 by 7 here, 5 by 3 here, and multiply together just like here. Okay, let's continue. So multiply the numerator. 5 times 26 is 130. Multiply denominators. 3 times 7 is 21. So 130 divided by 21. Let's continue here. Now we have, this is an improper fraction, and we have to convert that to a mixed fraction. So we're going to take groups of 21 from 130, and we can take 6 groups. Let's see what I did. So that gives me 6 groups, 6 whole number. When I take 6 groups of 21 from here, I got a 4 left. That's my remainder 4. So this is my remainder 4, and this is my denominator. Also divisor in the division nomenclature, and 6 is my whole number. 6 is the number of groups I got from 130. Okay, so 6 is a whole number, and 4 by 21 is my proper fraction part. When I multiply these two numbers together, I got 6 and 4 divided by 21. Let's continue. Another example, please. Another example. 2 1/3 times 1 1/2. Okay, let's continue here. First, we convert that to improper fraction. 2 1/3 converts to 7 by 3, and 1 1/2 converts to 3 by 2. Okay, now we're going to multiply numerator 7 times 3 and denominator 3 times 2. Let's continue here. So that's 21 over 6, and let's see what how to do that. Now we have to convert that into a mixed fraction. That means we have to find a quotient of this division, 21 over 6, and remainder from the division. Okay, quotient is groups of 6 I can take out is 3. I take out 3 groups of 6, leaving 3 behind. So what? So we got 3 and 3 by 6. 3 and 6 have a common factor 3. So we divide numerator 3 and denominator 6 by 3 and got a 3 1/2. Okay. We could have taken out this 3 here also. We can have taken our factor, divide this by 3 and this by 3, leaving 1 here and 1 here. That would have given me 7 by 2. So we decided to ignore extracting out 3 at this step. We did that. Do some examples, exercises here. When there's a off involved, that's the same thing as multiply by. Let's continue. So we do example is 2 and exercises. First exercise, 2 as a whole number 2/3 times 5 as a whole number and 5/7. Continue. Next exercise, 3 divided by 4 times 5 over 8. Next exercise is 7 divided by 9 of 3 divided by 7. Continue. Next, 17 over 11 times 4 divided by 9. Next, 21 divided by 13 times 26 divided by 15. Now we'll do an example for it with the 3 fraction, a multiplication with 3 fraction. Let's continue here, which is a 2 1/2 times 3 2/3 times 5 2/5. Let's continue. First, we have to convert all these mixed fractions to improper fraction. Okay, convert to improper fractions. Let's see what happens. What do we do? 2 1/2 converts to 5 by 2. 3 2/3 converts to 11 by 3. 5 2/5 converts to 27 over 5. Let's continue. Now we cross out the 5s. So there's 5 here and 5 here. Okay, and replace by 1s. Okay. Okay. So we divide this 5 by 5, got a 1, and we divide this 5 by 5, got a 1. Okay, let's continue. Now we divide 3's here. There's 3 in here and 3 in 27. We divide this 3 by 3 to get a 1, and this 27 by 3 to get a 9. Okay, continue here. So we got a 1 here and 9 here. Okay. Now we go to multiply out. In numerator, we have 1 times 11 times 9, which is 99. In a denominator, I have a 2 and a 1 and a 1. That's 2 times 1 times 1 is 2. Okay. Let's continue. That's 99 over 2. That is an improper fraction. Okay. Now we have to convert that to a mixed fraction. That means I would have to divide 99 by 2, find a quotient, and find the remainder. Okay. My quotient is 49, a remainder is 1. And improper fraction is 49 as a whole number, 1 by 2 as the proper fraction. Now, do some more exercises here. Okay. So we have a 2/3 times 1 and 1/8 of 2 and a 2/9. That's first exercise. Next exercise is 1 and a 3/8 of 2 and a 2/11 and of multiply by 1 and a 7/12. Next, I have a next exercise is 4 divided by 67 times 201 divided by 19 times 9 whole number and 21 over 42 as the fraction part. Do some divisions here. We'll use the sutra transpose and adjust to convert a divide by a multiply by. Okay, let's see what I mean by that. So we have 4 divided by 9, that's one fraction. 5 divided by 7 is the second fraction. We are trying to divide first fraction by 5 over 7, second fraction. Okay? So there's a division sign here. We can convert the division sign to a multiply sign and change the 5 over 7 to 7 over 5. So we'll transpose 5 over 7 to 7 over 5, and then along with that we'll change the sign divide by to a multiply by. So let's see what I do mean by that. So that means it becomes 4 over 9 times 7 over 5. Okay. Now we can do a multiply on the numerators and multiply in the denominators. Okay, let's continue here. So that is equal to 4 times 7, 28, and 9 times 5 is 45. Okay, let's continue here. Use crosswise instead. Okay, so now first we did is a transpose and adjust. Now we're going to try and do the same thing using a crosswise principle, which is vertical and crosswise. We use only the crosswise part of that. So it's a 4 by 9 divided by 5 over 7. Now the crosswise numerator is 4 times 7, 28, and denominator is 5 times 9 or 9 times 5. Okay, 40. So okay, and that is equal to 28 or 45. So we can do crosswise and keep the divide by sign, or we can do horizontally and apply transpose and just change the sign to a multiply by and take a reciprocal of the second fraction. Okay, let's continue with division here. Use the sutra transpose and adjust and convert divide by multiply by. Okay, then now solve as a multiplication problem. We have discussed that already, so I don't intend to discuss division problem any further because you can convert a division to a multiplication, and we have done that. Now let's do a next section here. Next section is simplify. So let's simplify an expression involving fractions. Let's continue here. In simplification, we have to consider precedence of operation. Precedence is also called order of operations. Okay, let's see what we do here. First, we resolve my bracket, then of, then division, then multiplication, then addition, then subtraction. Okay, let's see. First resolve bracket and then of. Finish up with division and multiplication, and only then do you touch addition and subtraction. These three lines we had jingle in our Indian language, which is said that पहले खोलो bracket को पीछे खोलो का. First resolve the brackets and then of. तकसीम जन्म को साफ बनाकर finish up with division and multiplication. Jama nafi ko haath laga. Only then do you touch addition and subtraction. These three lines were made a jingle in Indian language, which goes like that again. पहले खोलो ब्रैकेट को, पीछे खोलो का, तकसीम जर्ब को साफ बनाकर जमा नफी को हाथ लगा. Okay, let's continue, and we have to consider this order here when we simplify an expression involving of, parentheses, multiply, divide, and add, subtract. Let's continue here. In general, we simplify from left to right and keep the above precedent. If I do example here, it's 1/2 plus 3/4 minus 5 divided by 8 plus 7 divided by 15. Let's continue here. So there are no brackets, no off, no multiply, or no divide. Okay, so it's all add and subtract. They all have equal precedence. Let's continue here. So we simplify from left to right. Okay, first we do half 1 plus 3/4. Half plus 3/4 is, we replace that by 5 by 5, 4, because half plus 3/4 is 5 divided by 4. Okay, let's continue here. Okay, so we got a 5 by 4 here, minus 5/8 plus 7/15, minus 5/8 plus 7/15. 5/4 minus 5/8 is 5/8. 5/4 minus 5/8 is 5/8. Okay, and let's replace that. So we got a 5/8 plus 7/15. Okay, now we can do vertical and crosswise here. So multiply crosswise in the numerator, 5 times 15 plus 7 times 8. Okay, so numerator is 5 times 15 plus 7 times 8. In denominator, it's horizontally 5 times 18 times 15 times 8. 8 times 15. So let's continue. So that is 131 divided by 120. So this thing, 5 times 15 is 75, 8 times 6, 7 is 56, 75 plus 56 is 131. In the denominator, it's horizontally 8 times 15, which is 120. Okay? And that is a improper fraction, and proper fraction equivalent of that is 1 and 11 by 120. Okay, let's continue. So that's another example here. It's 3/2 plus 4/9 minus parentheses 1 and 5/18, 5 and 18 plus 7 divided by 9. Okay, so we have parentheses here. That's bracket. Okay, first we have to resolve the bracket first. Okay, let's do that. This is a 23 by 18 and this is 7 by 9. Okay, when you add them together, it becomes a 37 by 18. 27, 3 by 18 and 7 by 9 denominators are proportional. Okay, so that means we convert 7 over 9 to equivalent fraction such that its denominator is also 18. This is become 14. Then we add up, we got a two fractions with add sign and with the common denominators. So become 23 plus 14 is 37. So 37 divided by 18 is inside the parenthesis. Okay, let's go our bracket. Okay, let's continue. So I have a 3/2 plus 4 over 9 minus 5 over 18. Okay, now let's resolve. Let's see what we're going to do here. Now we have a 3 plus half. We just split the 3/2 separate. So 3 plus half plus 4 over 9 from here minus. We're just going to do this first. Okay, we keep the 3 here. We're doing left to right now. Okay, so half plus 4/9, okay, which is 3, and that's 9 plus 8 divided by 18. So this, I converted that into a fraction where the denominator equals 18. Okay, I made this equivalent fraction into 9 over 18. This is equivalent fraction into 8 into 18. Okay, so that becomes 9 plus 8 divided by 18. So our I also do that crosswise here. 1 times 9 is 9 and 4 times 2 is 8. That's crosswise in the numerator, and in denominator is horizontally 2 times 9. Okay, so which is equal to 3, this one, plus 17 over 18. Let's continue. So I have a 3 plus 17 over 18 minus 5 over 18. Okay, all right. So these, I want to hold on to 3 for a while and solve these. 17 over 18 minus 5 over 18. Okay, that's 12 over 18, and which is equal to 2 over 3. Okay, so we end up in 3 as a whole number plus 2 over 3, and that is a mixed fraction with the 3 as a whole number and 2/3 as a fraction part. Example here, simplify. Now I have 3 and 2/3 plus 7 over 69 times bracket, first fraction is 1 as whole number, 5/18 as a proper fraction, divide by, and second fraction is 7 as a, by 9, okay, bracket close, plus 4 divided by 9 of 9 divided by 5. Okay, let's continue here. We have to resolve the bracket first. That's my precedence order, which has a this mixed fraction comes to 23 over 18 divided by 7 over 19, 7 over 9. Okay, let's continue here. So what do? We transpose and apply. We don't like to do division, we do the multiplication. So we change divide by to multiply by, and change the second fraction 7 over 9 to 9 over 7. Okay, let's continue here. So this is what we have, 23 by 18 times 9 over 7. Okay, 9 and 18 have the same common factor 9. We take out 9 from here, become 1, and take 9 from here, become 2. Let's continue. So that you get a 1 here and a 2 here. Okay, we divided this 9 by 9, got a 1. Divide this 18 by 9, got a 2. Let's continue. So this is what we got. 23 by 18 times 9 over 7 is 23 by 14. 23 times 1 in numerator is 23. 7 times 2 in the denominator is 14. Okay, let's continue. Now we are going to replace this thing inside the brackets by 23 by 14. Let's continue here. So that's we got a same number here, that same here, and this parenthesis got replaced by 23 by 14, and rest copy just as it is. Okay, now we have to do off first. Okay, so we have to do this off. This is next precedence order. So 9 and 9 crosses out. We divide this 9 by 9, get a 1. This 9 by 9 got a 1. We have 4 by 5. Okay, we have. So now we're going to replace this part, which is 4 divided by 9 of 9 divided by 5 by the 4 by 5. Let's continue here. Okay, now next order process is multiply. So we are going to do that. 23 and 69. We divide this 23 by 23, get a 1. Divide this 69 by 23, get a 3. So we got a 1 here and 3 here. Now 7, same way. We divide out this 7 and 14 by 7. This become 1 here, and this become a 2 here. So this part 7 over 69 times 23 by 14 reduces to 1/6. That's what we're doing here. So that's the 1/6 here, and we're going to now replace this part by 1 over 6. Okay, continue here. So this stays, and this stays, and this part become 1 over 6. Okay, let's now we start adding them together, left to right. Hold on to 3 though. Okay, so this is what we have, and we're going to hold on to 3 and resolve left to right. 2/3 plus 1/6. So 2/3 plus 1/6 is 5 over 6. So we get 3 plus 5 over 6 plus 4 over 5. Okay, let's continue here. 5 over 6 plus 4 over 5 is 5 times 5, 25. 4 times 6, 24. In numerator we have it 25 plus 24, which is 49. And denominator we have 6 times 5, 30. Okay, so we get 49 by 30. Let's continue here. So we have 3 plus these two added to 49 by 30. 49 by 30 is an improper fraction. We got to convert that to mixed fraction. So what do? We have to make this division here and find a quotient and a remainder. How do we do that? We take groups of 30 out of 49. We take one group out and leave a 19 behind. 19 is a remainder, and 1 is the additional quotient we have. So next is, so that resolves to 4 as a whole number and 19 by 30 as a proper fraction part. Okay. No exercise given for this section here. Okay. And Glover's book 3 has exercises under mixed practice if you want to look for some book. Okay. Khan Academy does not seem to cover fraction problems under order of operations. Let's continue here. Wikipedia doesn't seem to include such examples under order of operations either. So, okay, there is hardly anything available online. Okay, And I have covered necessary examples, and you can go modify these little bit and do some more. Okay. Okay. Please refer to a suitable grade specific text for exercises on subjects. And book 3 is for 8th grade students. Okay. Now I have references here. Teacher's manual is my main reference, and it has some fractions issue. Tirsaji does not have a section on fractions. Vedic Math for School, I used that book 3 here as a guideline and covered the topics in the same order as they were in the Glover's book 3. Okay. Now this is my new reference I added. Kenneth Williams' book Discover Vedic Math. It covers fractions under the sutra vertically and crosswise. The book is organized not by the topics but by the sutras. As Vanna Singhal's book does not have a fraction. Okay, and so these are my references for you. Continue.